question number 1, I think. Yeah. A small mass or ball of mass m is moving in a horizontal circle. Now the inside surface of a frictionless hemispherical ball. Okay. Now this is moving like this. See, it's moving in a circle over here. Means what? Now you are rotating it like this. Okay. The normal force n makes an angle to the horizontal. So this is your normal force. Usually normal force will be perpendicular to the surface. State the direction of the resultant force of the ball. What is the resultant force? See, even though it is moving like this, see, if it was moving, if normal force is like this, so what is happening? If something is moving inside a circle, the resultant force will always be directed towards the center of the circle, which means it is directed like this. You should write state. Which means what? Acting towards the center of the circle. Next. On the diagram, construct an arrow of the correct length to represent the weight of the ball. So you need to mention the weight of the ball. So if he is showing you a horizontal circle over here, let us write down the forces over here. I write n cos theta. So this will be n sin theta. See, the projection of this vector here would be n sin theta over here. Okay, so I should not be drawing this n sin theta larger or smaller, because this vector is given like this. So then I should write the projection exactly. Okay. Now, the vector that is downward over here should also be of the same length. Okay. That is something which you need to remember. So this should be equal to mg. Why it should be of same length? Otherwise, if this is smaller, if I write only so much over here, then this is higher. So this will try to go spirally upwards. But that has not been shown, right? So it is only shown like this. If it is much lengthier over here, this will now start coming downwards spirally. Okay, that should not happen. So as a result of it, this is balancing with this one. Okay, next. So this has been shown. Anyway, we have to draw it here. I will draw it here. I will write this is to a, I will write like this. And I will write this as n sin theta. I will write an analogous vector here, which will be equal to mg. Okay, next. Show that the magnitude of the net force F on the ball is given by the following equation: F equal to mg by tan theta. Now, how do we show this one? What we do is, now we have this as your angle theta. This would be your n cos theta, right? And this is the net force acting over. Let us write down the force equations. What are the force equations here? We can now write, I'll write it here. Okay, I can now write F is equal to n cos theta, because F is a pseudo force. Okay, I cannot just do without this circular motion happening like so here. So I can write F equal to n cos theta, and then mg is equal to n sin theta. Okay, what is this F? If you ask me, this F is nothing but mv square by r. Okay, that's what it's, centripetal force. So I'm just writing it like this currently because he has given you as F. Let us see at a later stage whether we require mv square by r. We will enter that. Now we divide one by the other here. Why do I need to divide one by the other? Now you see here, this F equal to mg by tan theta is got, right? Somewhere F, g, tan theta all are related. So what I will do is I will simplify this and see to it that here is no value of n here. Okay. So therefore I am going to eliminate this here. I will write F by mg is equal to cot theta. Cos theta by sin theta is cot theta. Or in other words, F is equal to mg cot theta, or this should be mg divided by tan theta. So as F equal to mg by tan. Okay. Now how is the marks distributed? The marks is distributed like this: one mark here, and one mark here. All the 3 marks are properly distributed like this. Next. The radius of the ball is 8 meters at theta equal to 22 degrees. Determine the speed of the ball. Getting this 4 marks, this problem is considered to be one of the toughest problems for many students, because they have assumed it in a different way. They don't read the problem properly. I'll show you where they have made a mistake. Several times I asked this question in my exams, but most of the students have made a mistake. Now he says radius of the ball. Which is the ball? This is the ball over here, and this is the center. This is the radius of the ball. This is the radius of the ball. Now you see it says it's a hemispherical ball, which means what? It is not a parabolic one. It's completely sphere. Half sphere is being shown over here, right? So which means this is also radius, This is also radius. This is also radius, right? This is also radius. And what is the radius of circle? This is the radius of the circle. Radius of the circle is small r. This is capital R. This is also capital R. What I will do is I will write and put a triangle like this. So this is your A, this is your O, this is your B over here. Okay. Now let me go back over here. Now how are this small r and capital R related? The right angle triangle. So I can now say this is a hypotenuse. So this is small r over here. I can now say this is cos theta is equal to small r by capital R. Right? Small r by capital R is cos theta. Small r is equal to r times cos theta. This is what we get. Now what we will do is we'll come back here, and I will write here. First one is I'll write r is equal to r cos theta. We can do. What is he asking? Speed of the ball. Okay. Now if you look at this equation, f equal to mg by tan theta. I said that I am going to use mv square by r here. Mv square by which r is this? Is it capital R or small r? Small r over here, because the radius of the circle. So this should be small r should be equal to mg divided by tan theta. Okay. So this m and this m goes away. V square is equal to gr divided by tan theta. That's what we got now. Gr divided by tan theta. Now what we do is we'll write v square is equal to gr divided by tan theta and take this value of r. Why should I take this value of r? Because the value of r is not known to me, right? This value of r is given to me. This value of r is given to me. I do not know what is this value of r. So I will write this as g is equal to 10 multiplied by this r. What is this value of r? I do not know. I'll just write r cos theta divided by tan theta. I just write like so. Theta equal to 22 is given. So I'll write 10 into, what's the value of r? 8 meters into cos of 22 divided by tan of 22. Okay. I just substitute the values. So now this will give you 1 mark, and writing this equation, because this equation is also new, this will give you 1 mark. And finally, calculating of all this, substituting these values and getting the final answer will give you 2 more marks. Now let us calculate this value. Yeah, let's just find out cos of 22. Cos of 22. Cos of 22 is cos of 22. It's cos of 22 is 0.927. So I write this as 10 into 8 is 80 multiplied by 0.927. It's one more number of 9271 or 9272, because there's 1 8 over there. And tan of 22, once again. Tan of 22, what is tan of 22? Tan of 22 is here. So it is 0.0440. 0.4040. I will calculate both of them. Do mention this in steps. It's always good for you. Otherwise, if you miss somewhere using your GDC, you might not will not be able to calculate or track it back. That's why I do every step over here, so that you mimic the same. 979272 divided by 0.4040 is equal to 183.6. 183.6. It's the same answer. Let's take it out. It's 183.6. And what is this now? Are we missing anything? 183.6. Oh my god, this is just v square. We need to calculate the value of. Okay, that's why 2 marks are given. V is equal to square root of 183.6. Now let me take the square root of this. I'll put the square root here. It will give me 13.55. 13.6 meter per second. Thus, the answer is 13.6 meter per second. Okay. Next. Outline whether the ball can move on a horizontal circular path of radius equal to the radius of the ball. Outline whether this ball can move on a horizontal circular path. Now this is the ball over here. Now this is moving like this over here. Okay. Now mg force is acting over here. N was acting like this. Okay. This ball can move on a horizontal circular force. Now if at all, if this is your theta, if this n is sufficient enough for it to actually get this one, it will move in a circular path. Usually what happens is there is no force to balance this weight. As a result of this, the Okay, so this will be slightly inclined. Let's say here as no force to balance weight, hence it will move, it will not move in horizontal circle. Horizontal circle. Okay. Next, a second identical ball is placed at the bottom of the bowl and the first ball is displaced, so the height from the horizontal is equal to 8 meters. Okay, the ball is released, first ball is released, and eventually it strikes the second ball. The two balls remain in contact, determining maximum height reached by two balls. Which means what? The first ball is released from here, second ball it comes and hits over here, and these two join together because of the heavier mass. This might go until this height. I do not know what height it reaches. He is asking you what is the height it can go to it, and after that once again it comes back. Right? That's what he's asking. How do you determine that? So towards it, what you do is this. What is this now? This is at a height of so much. It has an energy equal to mgh. Now when it comes over here and strikes it, before striking, what is its energy? All the energy is getting converted to kinetic energy. Okay. What is the kinetic energy? Half mv square. So what I can do is I can just write mgh is equal to half mv square. This m goes away. So v square is equal to 2g, right? So therefore, this should now be equal to 2 into 10 multiplied by 8, which should be 160. In other words, v is equal to root 160. Okay, let us calculate what is the value of root 160. Root 160. Root of 160 would be 12.64 or 12.65. Okay, so therefore, it is a 12.65. Let me call this point as some point A. I can write VA is equal to 12.65 meter per second. So this is the velocity at which this ball will come and hit here. Now what I will do is apply conservation of momentum. Okay. Now you could have asked me why I am not able to apply the conservation of momentum at the beginning itself. Why shouldn't I apply here? Because you know there's a gravity acting here. I cannot apply my conservation of momentum. Conservation of momentum should be applied only when there is no force acting here. Then you will have one more question. If that is the case, there is no force acting here. Is it so? But here you know the normal force and the gravity will cancel each other. No other component is present at this point. Okay, and here, so as a result of it, I can apply my COM only. So now, what is my COM tells you? It tells me the velocity, the collision, the momentum before collision. What is the momentum before collision of the first ball? The first ball, it was m times VA. Momentum of the collision, momentum before collision for second ball, it was 0, is equal to momentum after collision of both the balls. They are stick together, which means what? The total mass is 2m. What is the velocity? Velocity I do not know. Let me call this as VBO. Okay, I'm going to find out the value of VB now. So now this m and this m goes away. So VB will be equal to VA divided by 2, which would be 12.65 divided by 2. How much will this be? 12.65 divided by 2 will be 6.32. 6.32 meter per second. 6.32 meter per second. Okay, this is your VB. Next, now we have this velocity of the ball over here. Now it starts going upwards. Both of these balls are going upwards. How long can it go? As long as its kinetic energy doesn't become 0, it keeps on going upwards. The moment kinetic energy becomes 0, what happens? The ball doesn't have energy and it immediately falls down, right? So therefore, let us say h is this one, the height over here. So both of these balls, if they rise up, this potential energy of this ball would be 2m times dh. Why 2m? Because the total mass is 2m. So therefore, I can now write half into 2m into VB square. V square is equal to 2m into g into h. Just 2m goes away. So therefore now we have this. Let us calculate this value. So we have h is equal to VB square divided by 2g. What's the value of VB? 6.32 square divided by 2 into 10. This is what we have. So let us calculate this value. Where is it? 6.32 6.32 square. This square here, 6.32 square divided by 20 will be equal to 1.99. 1.99 unit meter. So right answer is 2 meters. Okay. So therefore this is 2 meters. Okay. So thus I think we have come to an end to this particular problem. Let us see the next problem too. Thank you.